So today I am going to discuss the traversing of a binary tree. So I will discuss it in two parts. In today's lecture, I will talk about the type of traversing, that is in order traversing, pre-order traversing, and post-order traversing. And after that, we will discuss some examples that if a binary tree is given, how we will traverse and what will be the result. And in second part, I will discuss that suppose the traversing of a binary tree have been given, and then build the given binary tree. So in this lecture, I am going to discuss about the all these three binary tree traversing. Now, we have basically three types of traversing. There are three methods: pre-order, in-order, and post-order. Suppose this is the binary tree we have. So in pre-order, pre means this pre, in, or post, it is related to root node. It is related to root node basically. When we say pre-order, then it means we will traverse root first. When it is in order, it means it will be in between. And when it is post order, then it means we will traverse root at last. So in pre-order, there are three steps: visit the root, first step, then traverse the left subtree again in pre-order, and traverse the right subtree in pre-order. So it is again a kind of recursive approach of this method. So in pre-order, again I am repeating, रूट को पहले ट्रेवर्स करेंगे, देन लेफ्ट सब ट्री को प्री ऑर्डर में, एंड देन राइट सब ट्री को प्री ऑर्डर में. Similarly, in order traversing, we will traverse left subtree in order, then root node, and at last then traverse right subtree in order. In post order traversing, we will traverse left subtree in post order, then right subtree in post order, and after that visit the root node. So this is the three traversing approach methods we have for a binary tree. Now, we are taking some example to understand. Suppose this is the binary tree we have. In pre-order, the methods already I have discussed. What will be pre-order traversing? So firstly, we will visit this node, root node, that is A. So it will come A. I should use some annotation. Now, so this firstly visit the root node. So this A, in pre-order it is A now. Then left subtree in pre-order. So now again we will traverse this left subtree in pre-order. So just concentrate on this left subtree. So this is the root node. So again we will traverse this one, root first of this left subtree, then B. Then its left subtree. So this is the left subtree of B. Again in pre-order, so D will come first. So then D. Then left subtree, इसका left subtree कुछ है नहीं. Then right subtree. तो right subtree में we have G. So here we got G. So for this root node, this left subtree we have traversed. Now root node, this left subtree, then this right subtree, and again in pre-order. So again this one C root node, C root node, then its left subtree, then its left subtree. So its left subtree, you can see again the root node first, then E, then its left subtree H, its left subtree H, then its right subtree I, so it will be I. So for this subtree, this left subtree has been traversed. Its right one now, F. So this is F. So it is pre-order traversing. Now, in order traversing, same way, but the left subtree will be first, then root, and then right subtree, and again in order. So left subtree first. So before this root, we have to traverse this left subtree. Again, this left subtree in order. So before this root node of this subtree B, we will traverse left subtree. Again, this is the root node of this subtree. So left subtree first. इसका left subtree कुछ नहीं है. Then its root, that is D. तो D आ गया. Then its right subtree G. तो then G आ गया. Now ये left subtree B का traverse हो चुका. Then it's B. इसका राइट सबट्री कुछ नहीं है, तो ये पूरा लेफ्ट सबट्री ट्रेवर्स हो गया. तो इस रूट नोड ए का ये पूरा लेफ्ट सबट्री ट्रेवर्स हो गया. नाउ वी विल ट्रेवर्स ए. दिस इज ए. नाउ अगेन इट्स राइट सबट्री इन ऑर्डर. तो अगेन दिस लेफ्ट सबट्री फर्स्ट, and now in this left subtree, this left subtree first. So H will come first, then its root E, and then I. So this E and I, this left subtree has been finished. Now C, root node C, and then this right one F. So this is the in order traversing of this tree. Now again post order. So in post order, we will traverse left subtree in post order, then right subtree in post order. At last, we will traverse root. So here, this is the root. So firstly, this left subtree, then right subtree, at last root node. Now this left subtree. So this left subtree, again, we will traverse in post order. So then this left subtree, again, this is the root of this left subtree. इसका फिर लेफ्ट सबट्री कुछ नहीं है, तो फिर राइट सबट्री. तो G will be traverse first. So G. After that left कुछ नहीं था, फिर राइट सबट्री and then root D. Then this root D. Now for this subtree of B, left subtree has been traversed, right subtree है नहीं, then B. तो B. Now for A, left subtree has been traversed. Now right subtree. So again in post order right subtree, root. So first left subtree, again this left subtree H. So H will be traversed first. Then E का right I. Then E का left subtree हो गया, right subtree हो गया, then root E. अगेन हम सबट्री को भी पोस्ट ऑर्डर में ही ट्रेवर्स करेंगे. अगेन सी का लेफ्ट सबट्री हो गया, फिर इसका राइट सबट्री एफ, देन सी का लेफ्ट सबट्री हो गया, राइट सबट्री हो गया, देन सी. For A, left subtree has been traversed, right subtree has been traversed. Now this root node A. So root node A. So we can observe here in pre-order traversing, the root of given binary tree will be at first place, and in post order it will be at last place. So this is the one observation, we will use it. Now, uh, it is another example. So I am leaving this. You can check out again, and this is the traversing which have been given of in order traversing and pre-order traversing and post-order traversing. So you can do this and verify the result. In very short, I can say that this is the left sub root node, इसका right subtree नहीं है. So firstly we will in pre-order A will come, then फिर again left subtree, again this left subtree root will come, then B, then again its root C, then its root E, then this I, and so on. And similarly in order and post order. I'm not explaining it again. Now, there are some observation here. Like this example which have been discussed by me, you can see this is the kind of shortcut for pre-order traversing. Suppose this is the tree we had. So if you just move like this from root, just move from left and then try to traverse like this, like this, like this, and till last right side leaf node. And in the way, whatever node you get, just write down, it will be pre-order traversing. See, in the example which I have discussed previously, this was the ABDGCEHIF. This was the traversing. In this example, you can find out the traversing and you will get the same result you will get. So this is the shortcut for pre-order traversing. Now, this is the in order and post order traversing. Note, terminal roads D, F, G, L, and K are traversed in same order from left to right in all three traversing. So this is the one observation. In all these traversing, the order of leaf node will be same. And this is true for all binary tree. This is true for all binary tree. Another important point from this tree and this post order, I'm not discussing all these examples. You can do this by own and you can verify the result. The important point is here, in post order algorithm, every descendant of node n is processed before the node n. So in post order, basically जो descendant node है is processed before this one. So this is the some examples. Now, algebraic expression. We can represent any algebraic expression by binary tree and we have benefit of it. Suppose this is the expression we have, for example, a plus b minus c multiplied by d minus e divided by f plus g minus h. So this is the syntax tree, a kind of syntax tree. and it is also a binary tree. So we are representing like operator in internal node and the operand at leaf node. So like B minus C, to B, C operand, operator minus here. Then A plus B minus C. So this is B minus C. So A plus, so this will represent A plus B minus C. Similarly, D and E, that is minus sign, it become D minus C. Again, F plus G minus H, F and G operand at leaf, this node plus F plus G, again minus and here, and this H, this node will represent F plus G minus H. So D minus E divided by F plus G minus H, we can have this node. So this is the left operand represent D minus C, right node will represent F plus G minus H, and this is the D minus C divided by F plus G minus H. And at last we can multiply this one. So this is the syntax tree, and you can see it is a binary tree. Now, if you find out the pre-order traversal and post-order traversal of this one, so you will get this one. You will get this one. Now the observation. Pre-order corresponds to prefix notation and post-order corresponds to postfix notation. And this is true for all algebraic expression. So, like suppose we have this is in order, this is in order. You can build a syntax tree in the form of this binary tree and just trying to find out the pre-order traversal and post-order traversal, and you will get prefix and postfix equivalent. So this is the another way. We have already discussed the how we can convert infix to prefix and postfix by using a stack. So by using binary tree also we can convert. So this is the very good example of the use of traversing. Now, in the next lecture, I will discuss enough for today. In the next lecture, I will discuss if the traversing of a binary tree have been given. So, how we will build that binary tree. So, thank you. Enough for today.